Good morning, everyone. My name is Eric. It's my first time at NACIS. I'm excited to be here. Thank you to whoever found my badge last night, and I panicked a little bit this morning when I couldn't find it. We're here to talk about a project that we worked on at Stamen Design called Mapping Historical New York. So this is a project that we worked on with Columbia's Center for Spatial Research. It's an online map that shows how New York City's population changed over time. Do I need to get down? Thanks. And it shows it as granularly as possible. So this is actually at the individual level using census data. It's also, I won't be able to get to it today, but it's also a storytelling platform for researchers and students on top of that data. The data comes from the census. Some of us might know about the 72-year rule, where individual level data becomes available after 72 years. So this includes data right now from 1850, 1880, 1910. The data does not come to you with geographic information necessarily. So for some of these years, there were addresses, historic addresses that needed to be geocoded. Needed to be geocoded mostly using old fire insurance maps, but also 1850, the address information was really sparse. So what the Center for Spatial Research actually did was follow the steps that census takers took and determined the locations based on that. It was an incredible amount of work. Center for Spatial Research also collected custom coastline information, street networks, and points of interest. Lots of historic layers in order to actually tell the story in a way that makes sense. You can imagine this data overlaid on a modern base map maybe doesn't tell the full story. So our guiding philosophy working on this project was to make this resilient. For us, resilient meant minimize external dependencies, so we don't actually depend on anything outside of the website itself. All of the data is self-hosted, and we just don't use anything external to the site. We wanted to keep it cheap and simple, so everything is static. There's nothing happening server side. This is just in a simple storage bucket, and it could easily move if it needed to. This had a neat side effect. Originally, we were depending on the New York Public Library's Map Warper maps for historic base maps that were georeferenced. As some of you might know, that was archived in 2021 while we were working on this project. So since we were already planning on self-hosting everything, we just moved a bunch of those over to our server with permission in conversation with the New York Public Library. So the rough timeline, we originally worked on this in 2021. If you're interested, we blogged and podcasted about this around that time. There were a bunch of changes that happened in the intervening years by the Center for Spatial Research. They did some user interface work. They added more stories and narratives on top of it, which I encourage you to check out at mappinghny.com. That QR code should also work. But this year, we were really excited to revisit the project and relaunch it with some updated data and cartography. And Kelsey's going to walk us through that.
All right. So if you go to mappinghny.com or visit that QR code, you'll see a map that looks like this. This is the existing version of the site because the new one has not been launched yet. But this tool has all of the same data as the relaunched version that will come out hopefully in the next week or two. So you're getting an exclusive preview here of things that are not available yet. But this tool is really amazing. You can see, as Eric said, all of the data at the individual level, at the building level, and aggregated into choropleths with different geographies. And some of the challenges of this tool are mostly with the individual views that you see here. These are pre-generated rasters, and as we know, rasters are not the most flexible format, especially when working with data like this that you probably, like me, want to really dig into and explore and investigate on your own. Not a lot of interactivity is really possible using raster. I'll talk more about the differences between the building view and the aggregated view, but just some data things that we wanted to show, like things that were in the data that were not visible in the previous version of the map that will be, hopefully, when it comes out in the next week or two. So our design goals for this redesign were first to utilize vector styling. There are a lot of points on the map, as you might imagine. Quite a lot of people live in New York, and that's in a small space, so that's a lot of data to show at the same time in the same area. So that is definitely the biggest challenge that we faced during this redesign. We also wanted to update the visual design to make the data pop or shine a little bit more. I think there was a little competition between the base map and the data on top that we wanted to resolve with this new version. And then I think Eric mentioned that we'll be adding new data, new years, and more geographies in the upcoming version. So we wanted to make this approach more scalable and be able to add that data easily, so we don't have to redesign or relaunch every single time you add new data. So I'll talk first about the base map. You can see the top is the existing version and the bottom is the new version. Not a lot of changes happened here, like we still have all of the same data, but just visually making the map a little more neutral, a little more subtle, so colors like mostly the water are not competing with the colors on top of the map. Like I said, we want the data to shine, so giving a neutral kind of canvas for that data to sit on was really important. Other little changes we made were we can show, or we're using the same font on the map that we're using in the interface, so everything feels a little more seamless, like it works together and was designed together. And then some changes to how labels appear generally, like place labels should be big and prominent so you can know exactly where you are. And then some other changes, like this is very subtle, but as cartographers, you maybe noticed the roads. There was data in there that told us if it was a primary road or not. So, in modern base maps, typically a primary road or a motorway is a little bit thicker than a regular street or minor road. So adding changes like that to make it a little easier to know exactly where you are when you look at the map make a big difference in our opinion, and are easy to do because it's in this really great data that we had. So like we've been talking about, the biggest change is using vector instead of raster for this, what we call bswarm.density. As was the case before, every single dot represents one individual, but now these are aggregated by building, and they're visually represented as these concentric circles around the building. And because we're using vector now, this is more interactive, and I'll talk about how it's more interactive in a minute. So on the left here, you can see this is the same location on the old version and then in the new version. In the older version, people are pretty attached to this view. This is something that I think is important to say. When you have a tool that's out there for a few years and people use it a lot, they expect to see certain things, but that doesn't mean that what they're looking at originally is necessarily the most accurate or the best way to represent it. We call this the fire drill view. This is like if every person in New York went outside at the same time, then that's what the map looks like. But with all of that in mind, using raster here, a lot of the points bleed together. It's a little hard to see individuals. In the new version on the right, things are a little bit more orderly. The size is easier to see at this scale, and there's a lot less overlap and bleeding just because vector is a little more precise, and the circles are a little bit smaller also. We wanted to show a more complete picture, so the way that this map works is that you have up to 6 different colors, each one in the legend representing an attribute that is predefined by the subject matter experts at Columbia. So if the group that you're interested in is not in that list, is not visible in the legend, then previously they didn't show up at all. So this kind of makes it look like a lot of people who were there are not visible. So like there are more than 6 different birthplaces, for example, But if you have 6 that are set up by default, then what happens with those other people that are on the map? So in this new version, you can see, I think you could see it pretty well here, the circles that are just outlined with no fill, those are others. So those are people that are not in the colors that you've set up in the legend. And then when you zoom out, those are not visible, but you get that detail as you zoom in. So this is another nice benefit of using vector instead of raster. We don't have to, the transition between zoom levels is a lot smoother, and you can make those kinds of changes pretty easily. Also with vector tiles, like I said, we're using more interactivity, so you can hover over whichever attribute in the legend and see that highlighted on the map. This data is really beautiful when all of the colors are together and all the dots that you have selected are visible at once, but it can be hard to see, if you're just interested in one of the groups where they're distributed throughout the city. So this is a nice way to be able to do that. You can also now edit the predefined categories that you have in the legend. So the folks at Columbia, have told us that this is a meaningful distribution or meaningful selection of different birthplaces at this point in time. So it makes sense to look at them together. But maybe my interests, I want to see people from the United States instead of people from England. So I can change that first one, that yellow, to be United States as the birthplace. And now I have a totally different map that is maybe more relevant for me and my interests. Like I've said a few times already, I think rendering differences between raster and vector meant a lot of changes needed to happen in addition to just, switching to a new rendering technology. Raster was really weighting some of the colors, like some darker colors felt a lot darker, and then the brighter colors felt a lot brighter. So we needed to make some changes to account for that. And then I already mentioned, I think the sizing needed to be a bit different. And now that we're organizing the points in these concentric circles, there's less overlap. So in general, this is a pretty big improvement. And then finally, colors. We just worked on this in the last week or so. There are a lot of ways I think we could and have improved this color palette. Like I said, making the colors feel more equal to each other. We don't want one to dominate over another. And so you'll see the before and after color palettes and how those manifest on the right side in some different views of this data. Adjusted some of the assignments to make things a little easier to see, and the way like the colors will blend will make it easier to see patterns. Like that bottom right corner is showing gender, and so I think yellow is female and red is male, and so you can see where things are orange, it's like a lot of overlap, and where it's a little more red or a little more yellow, you can see that pattern a little bit better. We also tested these colors for colorblind friendliness, because that is obviously important to do, and making the tool as accessible as possible, so these colors work a little better for that as well. So that was a lot about the individual view, but we also have this view by building. We were previously just using markers, and now we've switched to using proportional circles. So you can see this is the same data in the old version and the new version. This is people from Italy and where they live in New York. Previously, you could just see that they lived in this location, and it could be one person, it could be 300 people. And now using proportional circles, you can see how many people, so a better sense of density of people and not just the location where they live. And then using a color instead of black, I think helped a lot. You can see this data a lot better, and it is shining instead of the base map maybe competing a little bit for attention. And then finally, we have this aggregated view that is a choropleth. This didn't change too much between the two versions, but we switched from yellow and orange to a monochromatic color palette. There was no need to really emphasize the higher end of the spectrum, so it just felt like something we could do to make it a little simpler. And then we also added a pattern where there's no data or null. As Eric said, this data is a little, it's from 1850 in some cases, so we don't have data for everywhere. And previously it was a little hard to see that, where it was 0 versus no data. And so now hopefully that's a little bit clearer to anyone using the choropleth view. And then in addition to the map, you can click on any one of the points and see a pop-up that has information about the dwelling that you're looking at. On the left, previously we just had a list of, any of all of the people that lived in that building and how they were aggregated into these different groups. We've replaced that with a table, so you can see there's a lot of hierarchy in this data, and so you can get a better sense of that. On the left, if you add up those numbers, you get more than 100% because of the hierarchy. So it makes a little more sense to see them kind of listed out in this way with a really basic little data viz with these bar charts, and those colors correspond to the colors on the map. So trying to make those connections for users. Students at Columbia use the tool in their class, and they copy, paste these into their reports. So we're hoping that this will help that be a little bit easier and a little clearer. And Eric is going to talk a little bit about experiments that we did. We got to this beautiful result, but it took a few attempts to get there. So I'll let you do that.
Great, thanks. So specifically, I want to talk about how we moved from the raster bswarm.density, we're calling it, to a vectorized version of that. For sure, we considered you could pre-generate vector tiles with every individual person, but we already had this information at the building level for a point in a building. So what we decided to try out was using a specific feature in MapLibreGL that I'm happy to talk about offline if you want details, but we used a feature where you could load the building's vector tile, inspect each building, and determine how many people should be there, and dynamically generate these concentric circles, and then output that as a vector tile that the map would display, which was really nice because you retain the interactivity that Kelsey was just walking us through, highlighting specific categories, changing the categories on the fly, and all of that. Another nice flexibility that adds, doing this dynamically, is you can play around with different shapes. So we kind of had a strong feeling from the beginning that concentric circles would be the way to go, but we wanted to try some other shapes. So you can see up in the top right there, playing around with rectangles for buildings. Each of these is just one building, showing all of the individuals in that building. In the middle, we have the concentric circles. On the bottom right, we have randomized within a rectangle. And we can see those side by side here for a similar area. So we ended up going with the concentric circles. I kind of like the rectangles. They are a little bit misleading because you might imagine that those are actually the shapes of the buildings. If we had the shapes of the buildings, we might have pushed a little bit harder on that, but unfortunately do not have the shapes of the buildings. Part of us definitely wanted to try to recreate like whole house maps or something here with the rectangles. Once we decided on the concentric circles, still have a bunch of choices to make in terms of what order to place the individuals within those concentric circles. And you can see in the top right, we were kind of the other category was ending up in the middle of the circles, which it's kind of an interesting effect, but probably not the most effective. And in the bottom right there, you can see there are some outliers, some buildings with just enormous numbers of people in them recorded in the census. So trying to manage how large those circles get was a fun part of this. So looking forward, as Kelsey has hinted at, we've not released this yet. There's a launch party set for October 22nd, so I'm really hoping it's all released by then. That'll be an interesting party otherwise. In addition to these updates to the cartography and the UI, the Center for Spatial Research has been working really hard to get additional data. So 30 years before what we currently have, 1850, and 30 years after in 1940. So that's coming, and also we've been showing just Manhattan and Brooklyn because that's all that exists right now. As you might know, there are 3 other boroughs in the city, they're expanding to those also. So Queens, the Bronx, and Staten Island. They're also improving the base map layers that we were talking about, so more points of interest, more place names, and coastline for all of Queens. And that's what we have. That's at mappinghny.com. Thank you.